This is module number 10. What is this? You're thinking, you're saying, okay, that's a pendulum. Yes. What affects the rate of swing of a pendulum? You're thinking friction, gravity, where I release it from, whether I release it from here, down here, or straight across. What else? How about the length of string? How about what's on the end here? This is a washer, but weight. Weight may affect it, right? Might affect it. Okay. So we're going to do an experiment, or I'm going to show you how to do an experiment, where we are going to decide. We're going to use two independent variables. In a classroom, I like splitting my classes into half the class doing one independent variable and the other half of the class doing another independent variable. The independent variables we're going to do string length and weight, but not weight like weighing something. We're going to use number of weights. And for the number of weights, I have an apparatus here, a little pendulum here with these little washers. I have a little paper clip that's kind of opened up. You can put one weight on there, 2 weights, and 3 weights. So we're going to do number of weights. Okay? So let me talk about both sides of the room, what each side is going to be doing. If you're doing string length, you will have a piece of string with one weight on it. This one weight becomes a control because you're not changing the weight. You're testing string length. What you're going to change, string length. That's your independent variable. Your dependent variable, what we're trying to find out, is the number of swings. Okay? So here's what you're going to do. Take a meter stick, and you're going to measure, upside down, you're going to measure from the end where it touches the weight, and you're going to, we're going to start at 50. So there's 50 about it. Right here's 50. And you're going to, any excess string, you're going to put in the cup of your hand. You're going to, so it doesn't get in the way. You don't want the pendulum to hit the string hanging down and mess it up. So now we're at 50 centimeters. How are you going to do it? How about your technique? Well, another one of your controls, where you release it from. We're going to release it straight out. Each time we do it, we're going to release it straight out. And we're going to let it swing for 15 seconds. 15 seconds. So you're going to have somebody timing it. Someone's going to have to go 3, 2, 1, go. 1, 2, 3, 4, 5. Now after 15 seconds, if it stops on this side, that's a full swing. If after 15 seconds it stops over here, it could be a half. So it could be 8.5, 9.5, whatever. You need to do more than one trial though. You need to have, the more samples the better. So do it 3 times. Take the average of those 3 times, and that's what you will graph. Okay? Now we're going to shorten the string. Now we're going to put it down again. Now we're going to go to 40. We're going to go to 40. Again, wrap the excess string in your hand, and you're going to go 3, 2, 1, go. 15 seconds, 3 times, take the average. Now, make sure you time it perfect. Make sure you release it. Don't go 3, 2, 1, go. Oops. No. Make sure you have a rhythm. Okay? 3 times, take the average. Then you're going to shorten it to 30. 3 times, take the average. 20, 3 times, take the average. And finally, 10, 3 times, and take the average. Now, 10's kind of strange because 10, it'll get to where it's almost stopped, but it is moving, and you need to count those as swings. Okay? So, string length is your independent variable. Number of swings, that's the dependent variable. Having one weight, that's a control. Releasing it from straight across, that's a control. And timing for 15 seconds, the number of swings, the number of what we call periods of swing. That's a control. Now, if you're in the number of weights groups, you don't need the meter stick anymore. You don't need that. But what you need to do is find a string length that you like, and you have to keep holding it in that one spot. This particular string has a knot. There's a knot right here. It's the first knot. So that's going to be where I'm going to hold it. Don't need to measure it, but I'm going to make sure I hold it in that same spot each time. So you take off the weights, and let's say we start with one weight. Here's one weight. 3, 2, 1, go. 15 seconds. Count the number of swings. Try not to move your hand around. Keep it steady. 3 times. Take the average. Graph the average. Then you go to 2 weights. Hold it in the same spot. This is very critical. Same spot. 2 weights. 3, 2, 1, go. 15 seconds, count. Remember, if it ends up over here, that's a hole. If it's over here, it's a half, right? 3 times, take the average. Then 3 weights, 3 times, take the average. To be even with the string length groups, they are doing 5 different, 50, 40, 30, 20, 10. You're only doing 1 weight, 2 weights, 3 weights. You could add 2 more weights to make it 5 and 5, but I don't know if this would hold 5 weights, so that's why I only use 3. Okay? Number of weights, the number of weights, that's the independent variable, that's what we're changing. Dependent variable, just like the string length, folks. Dependent variable, number of swings per 15 seconds. Control, release it straight across each time. Also 15 seconds time would be a control. Now, so let's say you've done this, you've made your graph, and the weight people, I usually don't like giving the secret away because I want you to do it. So if you're going to do the experiment yourself, turn off your computer or whatever you're watching and do it, and then come back to this point because I'm going to share the results. Now all of them's going to be a little bit different, but the number of weights, most people find the weight makes no difference. Weight doesn't matter. And your graph should look somewhat straight across. 1 weight, 2 weights, 3 weights. You got a really good title here. Identifies the independent variable, the number of weights, the number of swings of a pendulum, the dependent variable. Strangling. Look at this. 50, 40, 30, 20, 10. What effect does Strangling have on the number of swings of a pendulum? 50 at 50 centimeters. Guess I need to add centimeters in centimeters. 50, 40, 30, 20, 10. Now, how would you interpret that graph? Think. It looks like the shorter the string, the more swings we get. Yeah. And that's true. Think about it. What do we use in people's houses? An old antique. What uses the principle of a pendulum? How about an old grandfather's clock? The grandfather's clock have the pendulum swinging. It's got the weight down at the bottom. If it's going a little fast or slow, you can move that weight to make it longer or shorter to adjust the time, right? If you pull that weight down, it's going to make it longer, right? If you want to go faster, you move it up to make it shorter. How about children? Children use what in a playground? What do children get in the playground? It's a swing. I know you all did this. You've all done this. What did you do in the playground to make that swing go faster? Shorten the length of it by what? Wrapping it around the swing set or folding the seat up on itself to make it shorter. You get in it, you swing a lot faster. It'd be harder to get out. You have to kind of jump out, right? But children are using physics. They're doing science and don't even know it. Okay? So, pendulum. Good activity, teaching independent, dependent, and control variables. Okay.